Welcome to all uh, for the SWAM MOOCs course on the introduction to basic in veterinary diagnostic imaging. So, today we are going to discuss the lecture 21 basics of digital radiography in veterinary patients. So, first of all we will discuss about the digital radiography. So, in this lecture we are going to cover the topic in the form of introduction to the digital radiography. Under the introduction, we will discuss the process of the digital radiography, system of the digital radiography, classification of the digital radiography. Then under the classification, we will discuss about the computed radiography, that is also known as CR system. Under CR system, we will discuss the photo stimulable phosphor, exposure and readout, imaging plates, charge coupled device, etc. Next part of the classification is digital radiography. Under this, direct digital radiography and indirect digital radiography we will cover today. And we have also discussed the advantage and disadvantage of the digital radiography, and finally we will conclude the today's lecture. So, this is a total overview of today's lecture. Let us start with the introduction to the digital radiography. Actually, the digital radiography is the digital placement of the conventional X-ray film radiography. That means it removed the conventional X-ray film processing. In this process, we have to capture the radiographic data from the conventional X-ray machine and processing the data digitally to produce high quality radiographic image. So, this digital radiography historically produces or referred to a specialized modality that produces a digital image. Digital means we can numerically process the X-ray images or the radiograph. This is not possible in the conventional radiology. So that the digital images can be easily transmitted through the network and it can be achieved in the form of data. Let us discuss about the history of the digital radiography. As you know, the conventional radiography was started in early 1900th century, but it is having a very tedious procedure like processing of X-ray film, and many limitations are there. So that the evolution was started regarding this digital radiography in 1970s. In 1970s, the concept of the digital radiography was introduced, and the development of the digital subtraction angiography was also started in 1970s. The company Kodak in 1973 patented the first optically scanned storage phosphor system. Afterward, in 1980s, the computed radiography was emerged. So, in computed radiography, they were used photo stimulable phosphor plate. Then in 1980s, the first clinical use of the computerized radiography was introduced. The first computerized radiography was introduced by a company Fujifilm in 1983. Afterward, the many development was going on. In 1990s, the development of the direct digital radiography system was produced. Under this direct digital radiography system, there are use of flat panel detectors and it is CCD based system increased. In 2000s or in a millennium year, the digital radiography system become commercially widespread because it is very easy to use and the quality image is very good. That means in the DR system, it were found enhanced image quality, workflow and the data storage capabilities. In present day, the DR as well as the CR system is integrated with many communication system like PACS, Picture Archiving and Communication System, or cloud based storage and AI assisted diagnostic. It is widely adopted in veterinary and human imaging for fast and accurate diagnostics. Let's discuss about certain important points related to the digital radiography. In conventional radiographic images, spatial position and the blackening analog value are linked. While in the digital radiography, we are using a matrix which represents an image. A matrix is a square or rectangular area divided into the rows and the columns. That smallest element of the matrix is called as pixel. Each pixel of matrix is used to store the individual gray level of an image which represented by the positive integer numbers. The location of each pixel in the matrix is encoded by its row and the column number. Generally, it is denoted by X and the Y. So, the digital radiography process may have certain steps. So, under these steps, first step is image acquisition, then image processing, then image display in the monitor, afterward image archiving by various type of communication software or the systems, and image retrieving. So, these are the radiological process during digital radiography. Now, let us discuss a classification for the digital radiography. The digital radiography, as we have discussed, that started from the computed radiography system, CR system, then it goes toward the direct radiography system. So, it has divided into type like computed radiography, that is widely known as a CR system, and another is a direct radiography system that is widely known as a DR system. The computed radiography is further having certain property, like it is having indirect conversion property, and it has storage phosphor plate to store a X-ray or image. Now, direct radiography is having two type of conversion, like indirect conversion and the direct conversion. So, under indirect conversion, it contain scintillator, that is having thin film transistor, scintillator that is having charged coupled devices, and image intensifier. While the direct converter is having only photoconductor plate, which is having flat panel detectors and a selenium drum. So, let us discuss about the computed radiography first. So, the digital radiography that records the radiographic image on the photoestimable phosphor plate instead of film or screen image receptor in computed radiography. The acquired image data are covered to an electronic signal and digitalized, so they can be stored and manipulated by the computer and the displayed on a high resolution monitor or recorded on a film by using a laser printer. So, some other important point related to this computed radiography are like, in the computed radiography we use same radiographic equipment as a conventional radiographic system, so that you should not require to change X-ray machine. You can use the same old X-ray machine for the computed radiography, and you can use a imaging plate instead of a X-ray cassette. So, that imaging plate contains a photo-stimulator phosphor plate. So, that photo-stimulator phosphor plate is holded by a cassette, so that cassette reader is required. And finally, the image can be processed by a computer, can be sent to the communication software like PACS or DICOM. Let us discuss about the components of the CR system. So, for the computerized radiography system, the imaging plate cassette is required. This is a primary requirement, that cassette is containing the photo-stimulable phosphor layer, which is having a barium fluorohalide doped with the europium, and a laser scanner with photomultiplier tube is also one of the important component of the CR system. Then analog to digital converter, that is ADC, is also one of the component. Finally, the computer workstation is also required for image processing. The computerized radiography system introduce the key component involved the CR system used in a digital radiography. The CR system is also have a photostimulator phosphor. We have already discussed about that. We require exposure and the readout procedure, imaging plates and charge coupled device. These are the key components for the computed radiography system. Let us discuss one by one each component. So, first component is for photo stimulable phosphor, that is also called as PSP. This is a core technology behind the computerized radiography. So, under this PSP we are used reusable metal imaging plate which replaced the conventional film and the cassettes, and uses of the conventional bucky and the X-ray equipment can be used in this system. These are the special phosphor material, commonly barium fluorohalide doped with the europium, that store the energy from the X-ray when it exposed. This stored energy is later released as light when scanned by a laser. So, this process is called photo stimulated luminescence and can be read out later. So, let us discuss about the principle for the computerized radiography. So, the principle behind the photo stimulable phosphor plate in the digital imaging involves capturing and releasing energy from X-ray photons. Afterward, the plate store energy within the phosphor material which is then released as light when stimulated by a laser. So, you remember that laser is very important component in the computerized radiography. This light signal is converted into the digital image. So, this photo stimulable phosphor plate work by temporarily storing the information from an X-ray exposure and then releasing it as a light when stimulated, which is then captured and converted into the digital image. So, after discussing the principle of the CR system, we will discuss about the CR readout processing steps. So, under CR readout processing step, whenever the PSP plate can expose to the X-ray beam and this cassette with PSP is loaded into the reader system of the CR. The reader remove the phosphor plate from the cassette and it expose it to the laser which stimulating the phosphors. Whenever the light is interact with the phosphor layer, the light is emitted from the plate is collected and quantified and digitalized by the system. After readout, the plate erased using a bright light, so that you can again use that plate for next imaging. Now let's discuss about the reading imaging plate. The reader scan plate with the laser light is using rotating mirrors. Then the film pulled through the scanner by a roller. Afterward, the light is given off by a plate measured by a photomultiplier tube. That photomultiplier tube converts into this light to the electrical signal. That electrical signal is digitalized and finally sent to the computer for image display. Then you can learn how to read image by a plate. Now we will discuss about the laser and emitted light during computerized radiography. So the laser and the emitted light are different in the colors. So first the laser is used, which stimulates the phosphor layer. Then the intensity of the emitted light indicates amount of the radiation incidence on the phosphor at each location. Only color of light emitted by the phosphor measured by the photomultiplier tube. Let us discuss about the reading of the imaging plate. The plate is having photo stimulator phosphor. When it interacts with the X-ray radiation, the X-ray radiation trapped electrons in a high energy state. Then the higher state of the electron forms a latent image. Then the reader can scan the plate with the laser. The laser releases electrons trapped in a high energy state. Afterward, the electrons may fall to the low energy state whenever it will interact with the laser. Electrons gives up energy as a visible light. That visible light is very important. So that visible light intensity is measured of an incident radiation and recorded. Let us discuss some terminology which is used in the CR system, like CR throughput. A throughput is a speed at which the CR system process and deliver usable digital image from the imaging plates. It is generally slower than the film processing. The CR reader must finish the reading one plate before starting to read the next. So this is very important step, so that you can again take image in a same cassette. So, the film processor can run films back to back. Let's discuss about the next topic is charged coupled device, CCD, charged coupled device. In some CR system, a charged coupled device can be used to capture the emitted light. It is an integrated circuit made up of crystalline silicon. That means it forms the image from the visible light. For linear charged coupled device, detectors charge pocket at the very bottom of the linear array spills onto the transistor and produce an electronic signal that is digitalized. The entire line of pixel and readout in shift and read process. For 2D CCD detectors, the charges on each column are shifted on the bottom row of pixels. The entire row is read out horizontally, and then next charge from all columns are shifted down in one pixel. So, this is all about the charged coupled device. Let's discuss about the advantages of the computerized radiography system. So, in CR system, the major advantage is the CR plate you can use many times. That means the CR plate can be reused, and the CR system does not require any darkroom processing. It is very tedious procedure in conventional radiography system, so that it eliminates the darkroom requirement. In conventional radiography, we cannot change the contrast of the image, but in the CR system, the major advantage is that you can manipulate the image electronically. Then you will get a great dynamic range of image. So, due to that, you can reduce the exposure factor. That means you can reduce the exposure hazard to the patient. So, this is major disadvantage of the conventional radiography system. So, because of these advantages, the CR system is more popular nowadays as compared to conventional radiography system. So, one disadvantage is there. Disadvantage is only one, it is costly equipment. Due to the costly equipment, it should require a proper care and the maintenance of the system. So, let us discuss about the care and the maintenance of the cassette and the plate, because as you know, we are dealing with the animals. So, sometime the animal may get urinate, defecate, and give some dirty things over the cassette, so that care and the maintenance of the cassette and the plate is must. So, first of all, you should store the imaging plate in their cassette to protect them from the dirt and the damage. Do not store imaging plate and the cassette near to the radiator or the water source. So, damage or the dirt can result in streak or the artifact appearing in the diagnostic image. So that you have to very careful. Regularly you have to inspect the cassette for any type of damage, and you have to open the cassette and the close after cleaning the cassette with the help of technician. Then how to clean the imaging plate if you are using the CR system? Safely remove the imaging plate from the cassettes, wiping the plate gently with the dry, lint-free soft cloth. Remember this point. You have to wipe the plate with the dry, lint-free soft cloth. Never use a wet cloth to wiping the imaging plate, because it destroy or damage the imaging plate. If soil remains in the plate, then you can use a very mild moistened lint free soft cloth and gently wipe the sealed or soiled area of the plate. Afterward, gently wipe the moistened area with the dry lint free cloth to remove the residual moisture. If the soil remain against, repeat the process by using isopropyl alcohol. If possible, use absolute isopropyl alcohol or 100% of ethyl alcohol. So, this is all about the computerized radiography. Now, let us discuss about a direct digital radiography or DR system. So, again this is two type, direct as well as the indirect digital radiography. So, this digital radiography is quite popular in wildlife radiography. So, this digital radiography is having some receptors which provide a digital signal output, which potentially lower the patient dose than the computerized radiography or the conventional radiography. It is using high latitude as for the computerized radiography. So, under this digital radiography system, the major advantage is that you should not require any processor or reader, and image will available in lesser than the 15 second. You will get the image below the 15 second. How fast it is. So, much less work for the radio technologist. So, the indirect and the direct digital radiography is a technique in which the conventional silver halide film or photostimulant phosphor screen like radiation receptors are replaced by a photoelectric receptor. Remember this, it is replaced by a photoelectronic receptor which is connected directly to the computer. So, let us discuss what components are having the digital radiography. So, primary component or primary requirement is a X-ray tubes or X-ray equipments, which is generally used in the conventional radiography system, and the detector plates which is containing the TFT, thin film transistor, and charge coupled devices that is connected with the computer system. Nowadays, the Wi-Fi or the Bluetooth are using to connect these devices to the computer. It is very quick and fast. Let us discuss about the detector. So, under detector, we are using flat panel detector. A flat panel detector which is used in digital radiography, especially in the direct and the indirect digital radiography system, are the heart of the digital radiography system. That means it is a main component of the DR system. The detectors capture the image digitally in real time with high resolution and fast processing, so that they enable high quality imaging with reduced radiation doses compared to the older method. Because of its fast processing and best, you can say the best resolution, it is generally used in the wildlife radiography, in human being and animal being in dental radiography, etc. So, under this we will discuss first about the indirect digital radiography. The X-ray strikes scintillators which producing lights, and the plate is containing the photodiode array. This photodiode array converts light to the electrons. The intensifying screen is used in this indirect digital radiography, which is made up of cesium iodide crystal, and the photo detectors is made up of amorphous silicon. The electronic sensors are replace the light sensitive film emulsion, and the X-ray are absorbed in the screen, and the absorbed energy is then relayed to the photodetector by visible light photons. The ratio of the light sensitive area to the entire area of each detector eliminates is called as a fill factor. Okay. That means the fill factor is a ratio between the sensitive area and the entire area. Here in this picture you can appreciate or understand the X-ray photons are interact with the scintillator or the phosphor layer of the indirect DR plate, which convert X-rays to the visible light. That light converted into the electrical signal, and that electrical signal is processed by a computer and convert in the form of X-ray image or a visible image in a monitor. So, this is a whole procedure of the indirect conversion or indirect digital radiography. After indirect digital radiography, we will discuss about the direct digital radiography. The direct digital radiography is made from the layer of photoconductor materials, which is present on the top of a TFT array. The electrons are released in the detector layer from the X-ray interaction, which are used to form the image directly. The photoconductors is made up of amorphous selenium. The selenium is a main component of this direct digital radiography. The selenium has a high atomic number than the silicon, but it is still quite low compared to the conventional X-ray intensifying screen phosphors. So, you can understand with this image. So, this is a flat panel imaging array for the direct digital radiography under the direct conversion. Here the X-ray photons directly interact with the semiconductors present in the direct digital plate, which convert X-ray to the electrical signal, and that electrical signal goes to the computer, and computer converted that electrical signal into the X-ray image, and that X-ray image we can see in the monitor. So, this is a direct method. You can direct use a X-ray to form an image. So, because of that, you will find some certain advantage of the direct radiography. It provides 2 to 3 times more dose efficacy, and image is formed is rendered faster. Direct radiography or direct digital radiography offers superior throughput and improve workflow. Let us compare the direct versus indirect digital radiography. So, in the form of or in the feature of working principle, in the direct digital radiography, X-ray are directly converted into the electrical signal, while in the indirect digital radiography, X-ray are first converted to the light, then the electrical signal. Now, in the conversion type of feature, in DR system, direct conversion is there. In the indirect DR, you will find an indirect conversion. Detector material is used in the direct DR system is amorphous selenium, while in the indirect DR system, scintillator like cesium iodide, gadolinium, oxy, sulfide or photodiodes. So, intermediate step is required in indirect digital radiography. It involves the scintillator that emits the light, while in direct radiography it does not require. Image sharpness is higher in direct radiography, while in indirect you can say somewhat it is slightly lower as compared to the direct radiography. System complexity, it is more complex and expensive It is also, but indirect digital radiography, it is also expensive, but compared to direct, it is slightly less or less complex, okay, or less expensive. Application for the direct radiography you can use for the mammography, and it require high resolution. You can use in the small exotic animals. But indirect radiography you can use as a general radiographic procedure like that. Efficacy or efficiency in direct radiography will find better and the finer detail, while in the indirect digital radiography you will get a better for high sensitivity and the cost of the radiography. So, let us discuss some other important points related to the digital radiography system, like patient dose consideration. So, patient dose consideration the means the exposure necessary to produce a good image or directly related to the detective quantum efficacy to the detectors. The CR system require about twice the exposure of the corresponding 400 times speed screen film detector for the complete image quality. Follow the LRA principle for reducing the patient dose. LRA means as low as reasonably achievable. Always use optimized exposure factors like KBP and MAS. Always use shielding and the collimation to reduce a dose. Pediatric dose adjustment should also be important point to consider it. Prevent repeat exposure. So, these are the certain points you can just keep in your mind for patient dose consideration. Let us discuss about the digital image correction, because whenever you are viewing the image digitally, you have to correct the contrast, brightness, noise, gain, etc. in a image. So, for that you should require to know some terminology used in digital image correction, like dead pixel correction. It replaced non-functioning pixel with neighboring value. Another type of defect is column defect correction. It interpolate value in the defective rows or the columns. Dark noise correction, which subtract the dark current using the reference frame. Flat field correction or gain and the offset correction. The variation in the pixel sensitivity can cause a non-uniform brightness across the image even under the uniform exposure. Geometric correction. This addresses issues such as image distortion due to misalignment of the detector, sources or the optics. So, these are correction you can just do during image reading. Let us discuss about the processing. Processing is performed by altering the relationship between the digital number, it is also called as a pixel value, in the image and display the brightness. The common image processing technique include the windowing, leveling and the contrast reversal. Under windowing, the adjusting the range of pixel value, it is also called as window width, displayed to the enhanced contrast. Leveling, it is a setting of the center value, it is also called as window level, around which the window width is applied, determining the image brightness. Contrast reversal, it inverting the black and the white value to highlight the different structure or the features. Care and the maintenance. So, for the DR system, so do not hit the DR plate with the repetitive high energy raw radiation. Careless handling can shorten the useful lifetime of the digital imaging detector. When there is a risk of fluid containing detector, place the detector in a protective bed. If you are using a protective enclosure around the detector, remove the enclosure immediately after use to prevent the detector from overheating. When storing DR plates, store somewhere secure where the DR plate can be laid flat and cannot be fall. So, these are the certain important points you should be keep in your mind for care and the maintenance of the DR system. Cleaning of the DR plates, do not operate the equipment when cleaning the equipment. Do not spray the cleaning solution directly onto the equipment. If you want to clean the plate, you can use a moistened cloth with the 70% isopropyl alcohol solution and apply to patient to the contact area after each contact. Do not immerse the equipment in a liquid. It destroys the plate. So, you should be very careful. Consider purchasing approval clinical cleaning lint wipe. So, these are the certain points for cleaning of the DR plates. Let us discuss about the DR system maintenance. So, do not attempt a mechanical or electrical repair of the system, and the system must be repaired only by an authorized service personnel. So, you have to keep this in your mind. Always call authorized service personnel. The system must be maintained in a good operating order at all time to provide safe condition for the technician and the patients. The system must also be maintained to prevent possible loss of patient or the image data. So, let us discuss about the advantage of the digital radiography. Immediate image preview and availability is one of the major advantage of this digital radiography. It eliminates the costly film processing steps. A wider dynamic range which makes it more forgiving for over and under exposure, as well as the ability to apply spatial image processing techniques that enhance overall display quality of the image. After advantages, certain disadvantages are also there. So, let us discuss about the disadvantages of digital radiography. One of the main disadvantage of the digital radiography is high startup cost, as I have already told you, but generally this is accepted due to the long term benefit of the system and it recouping the cost over time. With computed radiography system, images need to be processed almost immediately, as any delay will result the loss of image due to trapped electron returning to the lower energy state. So that immediately you have to process the image. This tends to a problem in the field of radiography, where images are required away from the practice. So these are the certain disadvantages of the digital radiography. Now finally we will conclude the today's lecture with the following points. The digital radiography, DR and the CR, has a revolutionized veterinary imaging with faster image acquisition, improved image quality and better patient care. It enables real-time diagnosis, efficient storage and easy sharing of images for consultation and referrals. Lower radiation dose and the post-processing capabilities enhance both safety and diagnostic accuracy. Routine correction, for example, dead pixel or dead noise, and processing tools, for example, windowing, labeling, ensure the optimal image clarity. The DR is increasingly preferred over the CR due to higher throughput, less handling and instant image access. So these are the conclusion for today's topic. Thank you for listening.